In this video, I am going to use the fundamental theorem of calculus part 1 to find the derivative of this integral x to x cube e to the power negative t square dt. So let's go ahead and kind of manipulate the integral a little bit first. So let's do it here. Integral x to x cube e to the power negative t square dt. I could write it as integral x to 0 e to the power negative t dt, negative t square dt, plus integral 0 to x cube e to the power negative t square dt. I can do that. I can break an integral into two pieces. Now, this I could rewrite as integral negative integral 0 to x. If I reverse the limits of integration, then or if I switch the limits of integration, the sign changes. So e to the power negative t square dt plus integral 0 to x cube e to the power negative t square dt. So finding the integral of this in essence boils down, finding the derivative of this in essence boils down to finding the derivative of these two terms. So which, by the way, is going to be d over dx integral 0 to x. Okay, I'm going to put the negative here. Okay, negative integral 0 to x e to the power negative t square dt. That's the first one. And the second one is going to be d over dx integral 0 to x cube e to the power negative t square dt. This one is very easy, which is going to be nothing but negative e to the power negative t square by the fundamental theorem of calculus part 1. This is the antiderivative, right, of e to the power negative t square. So remember, integral 0 to x e to the power negative t square dt is this function, if we call it g of x, is going to be antiderivative of e to the power negative t square, because e to the power negative t square is continuous on the interval under consideration. So sure, that's fine. However, we kind of need to play around with this thing a little bit. So let me do that part here on the side. D over dx integral 0 to x cube e to the power negative t square dt. What I'm going to do, I'm going to do a little bit of substitution here. So I'm going to say u is equal to x cube. Then my du over dx is going to be 3x squared. So this integral, I could rewrite it as d over dx integral 0 to u. Now I am just replacing x cube by u e to the power negative t square dt. Now I'm going to use the chain rule. So what I'm going to do, I'm going to go ahead and rewrite it. So this is going to be d over du integral 0 to u e to the power negative t square dt. Now look, this looks like the antiderivative definition, right? Look here. Times the derivative of u with respect to x. So this is going to be nothing but e to the power negative u square, okay, according to the fundamental theorem of calculus part 1, times du over dx. But e to the power negative u square, but my u was x cubed, so u square is x to the power 6, times du over dx is 3x square, so 3x square. So this is going to be plus this guy, 3x square e to the power negative x to the power 6. So the integral, the derivative of this integral is going to be nothing but this. And to do this, all we have done is just reorganize this one so that it conforms to the standard structure for antiderivative, okay? And then For the second expression, we just use the substitution and chain rule. I hope that this discussion was helpful. Thank you very much.